Hello GCC students, in this video we're going to work 3 stoichiometry problems. But first we need to write and balance the reaction of hydrochloric acid and solid cadmium. So this is from a couple of chapters ago. Let's see what you can do with that. HCl aqueous plus CD solid. First ask yourself, what type of reaction is that? And then hit pause and see if you can write and balance this reaction on your own. It's good practice. You're going to see lots of balancing and writing reactions on your final. Okay, we're back. So we have HCl, aqueous, and solid CD. Is CD a metal or a nonmetal? Well, it's right there. It's definitely a metal. So we have a single metal by itself. What kind of reaction is that? Single replacement. Single replacement means we need to look at what? Our activity series. And we're comparing the two metals in the reaction or the metal in H. Well, in this reaction, we have an acid, hydrochloric acid. So we have H and CD. Now, CD is more active. That means CD would prefer to be bonded to a non-metal partner. But it's not, it's by itself. So we're definitely going to have a reaction. What is CD going to bond with? Well, it needs something that'll be negative because CD is a metal and it likes to become a cation, CD plus 2. So it needs something negative to bond with it, right? Opposites attract, pluses and minuses attract. So the Cl is -1 charge when it's an ion. So yeah, that's going to go together and hydrogen will be left alone. How is hydrogen when it's by itself? I hope you remembered hydrogen is diatomic. So the reaction looks something like this. Hydrochloric acid plus cadmium solid makes cadmium chloride and hydrogen gas. Now, why is it CdCl2? Well, it's the charges, right? Remember, you got to check your charges. Cd is a +2, Cl is a -1. So that doesn't add up to 0. You need 2 Cl's at -1 each to make -2 to go with the +2. 2 minus 2 is 0. You have to have your charges add up to 0. And then hydrogen is diatomic, so it's H2. Then we balance it, and it's balanced just by putting a 2 in front of the hydrochloric acid. All right, so now we have our balanced equation. Number 1, how many grams of hydrogen gas will form if 5.00 grams of cadmium reacts? So we have two chemicals. We have hydrogen gas and we have cadmium. So we have two chemicals, a balanced equation. That means it's stoichiometry, and we're going to have a mole ratio in the middle. I want you to hit pause and solve this now. We've done a couple of these. It's your turn. You practice this. Okay, we're back. Let's look at our solution. There we go. We start with what we're given, the 5.00 grams of cadmium. We need to go from grams to moles so we can use that mole ratio. Cadmium's molar mass is in the periodic table. There's cadmium. 1 mole of cadmium over 112.41 grams of cadmium. Grams of cadmium cancel out. We're left with moles. Now we can do that mole ratio. We have 1 mole of hydrogen over 1 mole of cadmium. It's a 1-to-1 ratio, but moles of cadmium cancel out. You can't skip this step. You've got to show the moles of cadmium canceling out, and we have moles of hydrogen on top. But it didn't ask for moles of hydrogen, it asked for grams of hydrogen. Hydrogen is H2, so we need 2 times 1.01 to give us 2.02 grams of hydrogen per 1 mole of hydrogen. Moles of hydrogen cancel out. We're left with grams of hydrogen. What did the question ask? How many grams of hydrogen? So we've got it set up correctly. Grams of cadmium cancel. Moles of cadmium cancel. Moles of hydrogen cancel. We have grams of hydrogen. Punch it into your calculator. Sig figs. We started with 3 sig figs. We have 5 sig figs in the molar mass of cadmium. We have 3 sig figs in the molar mass of hydrogen. So we go with the least 3 sig figs, so 0.0898 grams of hydrogen. All right, number 2. If 2.374 grams of hydrogen gas formed, how many grams of HCl reacted? Again, we've got 2 chemicals. We've got hydrogen and hydrochloric acid. 2 chemicals, we've got our balanced equation. Hit pause and go. Okay, it's your turn to practice. You know you're going to see these on your next exam and the final. Your turn to practice. All right, we're back and let's look at the solution. We start with what we're given, 2.374 grams of hydrogen. We need to go from grams to moles. That means we need the molar mass of hydrogen. There's 2 H's in hydrogen, so 2.02 grams of H2 and 1 mole of H2. Grams cancel. Now that we have moles, we're ready for our mole ratio. There are 2 moles of hydrochloric acid per 1 mole of H2. Moles of H2 cancel. Now we have moles of HCl, but it needs grams. So we have to go from moles to grams, which means we need a molar mass. We're going to add up an H and a Cl. That gives us 36.46 grams HCl in 1 mole HCl. Remember, a molar mass is 1. You add up one of them. 1 HCl. Anyway, moles of HCl cancel. We're left with grams of HCl. Punch it into your calculator. You get 85.7 grams of HCl. Why the 3 sig figs when we started with 4? Well, we started with 4 sig figs, but the molar mass of hydrogen only has 3. The molar mass of HCl has 4, but you have to go with the least, which was the 2.02, 3 sig figs. So our answer has 3 sig figs. Pay attention to sig figs. Pay attention to units. Grams of hydrogen cancel. Moles of hydrogen cancel. Moles of HCl cancel. We're left with grams of HCl. All right, good job. All right, let's try a new one. Write and balance this reaction. HCl gas plus oxygen gas produces chlorine gas and water vapor. Again, this is great practice for writing a reaction. Hit pause and write that reaction out for me. All right, hopefully your reaction looks something like this. 4 HCl gas plus 1 O2 gas makes 2 Cl2 gas, chlorine's diatomic, plus 2 H2O gas. Water vapor means gas. All right, there's our balanced reaction. Let's look at our question. How many grams of chlorine can be formed if 3.070 grams of oxygen gas react completely? Don't worry about the STP. So we have chlorine and oxygen. We have two chemicals and a balanced reaction. So we can do our stoichiometry, which means there's a mole ratio in there in the middle. All right, hit pause, work out this last one. And we're back. Let's look at our answer. Here we go. We've got 3.070 grams of oxygen. Oxygen is diatomic, so the molar mass is 2 O's. So 32.00 grams of O2 and 1 mole of O2. Grams cancel. We're ready for that mole ratio. 1 mole of oxygen is on the bottom. 2 moles of chlorine is on top. 2 to 1 mole ratio. Moles of oxygen cancel. Now we need the molar mass of chlorine. So you just add up 1 unit of Cl2. Right, so 1 mole of Cl2 is 70.90 grams of Cl2. Moles of Cl2 cancel. We're left with grams. The question was how many grams of chlorine? So we got that. So it is 13.60 grams of Cl2. 13.60. 4 sig figs for this problem. All right, you did very well. We'll look at some more stoichiometry problems in the next video.